Welcome everyone. My name is Brandon Reed, and this is my final project for BA 513 Contemporary Analytics, where I will be developing a machine learning model to predict airline customer satisfaction. Our objective is to utilize the 7-step business analysis process to identify key factors that influence customer satisfaction level. First step is understanding the business problem. Second step, understanding the data set. Third, preparing the data set. Fourth, model development. Fifth, model evaluation. Sixth, communicate the results. And lastly, the model deployment process. Step 1, understanding the business problem. The goal is to develop a machine learning model that can accurately predict airline passenger satisfaction based on survey data. By identifying key factors that influence satisfaction levels, the airline can enhance the passenger experience, boost customer loyalty, and improve overall service quality. In the highly competitive airline industry, passenger satisfaction is a critical determinant of success. Satisfied passengers are more likely to become repeat customers, recommending the airline to others, and provide positive reviews. Conversely, dissatisfied passengers can harm the airline's reputation and lead to revenue loss. Understanding the drivers of passenger satisfaction and dissatisfaction is essential for making informed decisions and implementing effective strategy to improve the passenger experience. Some key questions that I asked myself while working through this project. What factors are highly correlated with the passenger satisfaction or dissatisfaction? How well can we predict passenger satisfaction based on these factors? And how can our findings be applied in deploying the model? Step 2 is understanding the data set. The data set for this project includes a comprehensive airline passenger satisfaction survey capturing responses from 25,976 customers. Of that, 14,528 responded as neutral or dissatisfied, while 11,365 responded as satisfied. Some of the other attributes within this data set is demographic data, which includes age, gender, and travel frequency, which helps us understand how different passenger profiles influence satisfaction levels. Next is customer loyalty. This measures repeat customer data to evaluate their impact on satisfaction. Flight class differentiates between economy and business travel experiences. Other attributes such as in-flight amenities. This covers amenities such as Wi-Fi, entertainment options, and meal quality, assessing their contribution to overall comfort. The booking process, so it evaluates the process and efficiency of the overall booking process. Overall comfort. This helps judge seat comfort, legroom, cleanliness, and overall in-flight experience. And then lastly is satisfaction level, categorized as satisfied or neutral or dissatisfied, which helps gauge the overall passenger sentiment. Step 3 is the data preparation process. During my initial audit of the data, it appeared fairly clean with little manipulation needed. Initial observations, though, was that the only missing data was in the arrival delay in minutes, which was missing 83 customers' response. For simplicity, I removed these attributes in Excel and then re-uploaded the data to RapidMiner. When preparing to run the model, I will exclude the following attributes as they will not be beneficial: ID, age, and gender. Age and gender are identifiers that contain sensitive information on customer privacy and will not affect the output of the model. And then ID, we removed ID just to potentially skewing the data. Next, within the auto model feature in RapidMiner, I also selected satisfaction as the Y variable to compare the data against. Later on in the report, I will also highlight the steps I took to split the data into testing and training sets when constructing the model manually. So in summary, for our data preparation process, we retrieve the airline passenger data. This process begins with loading the data set containing airline passenger information. Then I selected the attributes. Specific attributes relevant to this analysis are selected from the data set. This step ensures that only the most important features are used in the modeling process. Then I set the role, in this case, which was customer satisfaction, and then split the data. The data set divided into training and testing sets. This is a crucial step for evaluating the model's performance on unseen data. Step 4 in the business analyst process is the model development. Once the data was uploaded, cleaned, and prepared for modeling, I started the auto model feature in RapidMiner. This is a great starting point because it simplifies the process of building and validating machine learning models. In my case, I want something that has high accuracy and recall, a low error rate, and processes at a fast runtime. Based on my criteria, the decision tree model proves to check all of the boxes while delivering strong results. You can see on the screen from the AutoModel RapidMiner process screen that the decision tree model has a 93% accuracy. I also checked and it has a 95% recall, which is really good. And then it has a quick runtime. You can see on the right side of this screen, they all relatively have quick runtimes with the exception of gradient boosted trees, which have the longest. Long runtimes can make it difficult when developing a model at scale. So even though that the gradient boosted trees had slightly better performance metrics when looking at accuracy here, to me it wasn't enough to outweigh the fact of the more complex and how long it would take to run the model when deploying this at scale. To further the analysis and ensure we're creating the best performing model, I developed a decision tree model manually to compare. First, in the blank process screen, I added in the clean data, and then we continue by selecting the attributes that I used. At this point in the process, we use all of the attributes except for age, gender, and ID, which I called out earlier. Next is to select the label, which in our case is customer satisfaction. The next step in preparing the data for analysis within the manual model is to split the data into testing and training. This is crucial for model validation, as by dividing the data set into training and testing sets, you can train the model on one portion and validate the performance on another, ensuring that the model generalizes well to unseen data. You can see it on the screenshot on the page that I divided it into 70-30 split, training being 70%, which has 18,000 rows, and testing 30% of the data, which has 7,700 rows. Once the data is split, I added the decision tree model operator, apply model operator, and the performance operator. The last step in setting up the model to run is to add performance metrics to compare the outcome of the manual model versus the auto model. For performance metrics, I selected accuracy, recall, classification error, and correlation. Initial results. The auto model decision tree had an accuracy of 94%, while the manual model had an accuracy of 91.7%, proving that the auto model is slightly better with this dataset. However, both did perform very strongly. Continued refinement of the data. Another benefit of leveraging the auto model process is to utilize features of certain models that might not be available in others. For instance, the generalized linear model can measure p-values, which can help us refine the data to only measure statistically significant values. After reviewing the results of the generalized linear model, the following attributes were found to be not significant in determining satisfaction with a p-value of greater than 0.05. Flight distance, gate location, food and drink, in-flight entertainment, and departure delay in minutes. By doing this extra step, we were able to improve our decision tree metrics and further refine our model. Our performance metric went from 93% to 94%, so we gained an extra percentage there. Our classification error went from 7% error down to 6%, so we improved our error rate by 1%. And then our recall increased from 92% to 95%, so we gained 3% on our recall. Step 5 is the model evaluation. As you have seen up to this point, I've evaluated the model performance using metrics such as accuracy, recall, and classification error. Additionally, I evaluated several tools including correlation, ROC chart, confusion matrix charts, and a lift chart to evaluate the model further, which I'll go into each of those in the following slides. Correlation. Attributes highly correlated with airline passenger satisfaction include business class travel, seat comfort, in-flight entertainment, reliable Wi-Fi service, high quality in-flight service, an easy and efficient booking process, overall in-flight comfort, such as cleanliness and legroom, and strong customer loyalty programs. On the other hand, areas with a negative correlation to satisfaction presenting opportunities for improvement include factors like dissatisfaction with the online boarding process, certain aspects of in-flight service that may not meet expectations, and economy class, suggesting the airline should evaluate steps to improve the experience for those customers. By addressing these negatively correlated areas, airlines can further enhance the passenger experience and increase overall satisfaction and loyalty. The ROC chart compares the performance of all models evaluated. The chart plots the true positive rate against the false positive rate for each model. Models with curves closer to the top left corner indicate better performance. In this chart, the gradient boosted trees, generalized linear model, deep learning, and decision tree models have ROC curves near the top left corner, suggesting their strong performance. Our next tool is the confusion matrix, which evaluates the performance of a classification model predicting airline passenger satisfaction. And I'm going to get a pointer out to walk you through it. So from the predicted satisfied, which is in the top left here, true satisfied, which means the customer was satisfied and the model predicted that the customer is satisfied, was 2,999 instances were correctly predicted as satisfied. False satisfied, there were 192 instances predicted as satisfied when in reality they were actually dissatisfied response, which is a 93% precision on predicting satisfied cases. And then predicting neutral or dissatisfied, so there were 246 instances, which is highlighted right here, where the model incorrectly predicted as neutral satisfied when the customer actually responded as satisfied. However, there were 3,961 instances correctly predicted as neutral or dissatisfied, for an overall precision of 94% on predicting dissatisfied cases. Overall, the model demonstrates strong predictive performance, being able to correctly predict both satisfied customers and dissatisfied customers. The next tool that we use to evaluate the performance is a lift chart. The decision tree lift chart that you can see on the screen demonstrates the effectiveness of the decision tree model in identifying neutral or dissatisfied individuals across different population segments. The teal bars represent the model's accuracy within each segment. The green line indicates the cumulative coverage of neutral or dissatisfied individuals, starting at 17% for the first 10% of the population. So again, to get my pointer out, this first bar represents the first 10% of the population, and then all the way to 100% of the population. Within the first 50% of the total population, so you can see these first 5 green columns, our model can accurately predict 86% of unhappy or neutral or dissatisfied customers. The chart highlights the model's strength in accurately identifying a high proportion of neutral or dissatisfied individuals early on, making it a valuable tool for targeting interventions and improving overall customer satisfaction. Step 6 is overall findings and results. The decision tree model demonstrates exceptional performance in predicting airline passenger satisfaction with an impressive accuracy of 94.1%. The model's classification error rate is relatively low at 5.9%, indicating a high level of precision in its predictions. Furthermore, the model achieves a remarkable recall rate of 95.4%, showcasing its effectiveness in correctly identifying the majority of satisfied and dissatisfied passengers. However, there is some potential data points to enhance the model's performance, in my opinion, that the current data set is lacking. First being detailed demographic information, including more granular demographic data such as income levels, occupation, and education could provide deeper insights into passenger satisfaction trends. The other data point that I think it's lacking is loyalty program tiers. So information on the specific tier within loyalty programs, for example, silver, gold, platinum, things you're typically familiar with an airline like Delta, may reveal differences in satisfaction levels among frequent flyers. And then lastly is customer feedback and reviews. Incorporating qualitative feedback and reviews from passengers could provide valuable context and identify areas for improvement that are not captured by quantitative metrics. Step 7 and the final step of our process is the model deployment strategy. Deploying the decision tree model predicting airline passenger satisfaction involves several key steps. First, integrating with existing systems. Integrating the model with CRM, customer relationship management, or booking systems for real-time and batch processing. Deployment infrastructure. So choose a scalable infrastructure, for example, Google Cloud, to handle the data efficiently. Real-time batch processing. Implement real-time prediction for immediate feedback and batch processing for periodic analysis. Monitoring and maintenance. Continuously monitor the model's performance and retrain with updated data as needed. Next is establishing a feedback loop. Establishing a feedback loop to gather user feedback and improve the model's accuracy over a longer period of time. Reporting and insights. Generate reports and dashboards for stakeholders, highlighting key metrics and actionable recommendations. And then lastly, compliance and security. Ensure compliance with data privacy regulations and protect sensitive customer information. A real-world example that I would like to leave you with is a case study on Southwest. Recently, Southwest announced enhancements to transform customer experience and improve financial performance. Southwest has been known for its open seating policy. Well, that is changing in 2025 to an assigned seating model. By moving to an assigned seating model, Southwest expects to broaden its appeal and attract more flying from its current and future customers. Additionally, to assigning seats, Southwest will offer a premium extended legroom portion of the cabin that research shows many customers strongly prefer. After generating enough data and hearing from customers, Southwest knew a change was needed to increase revenue and customer satisfaction. When it comes down to it, customers when traveling want certainty, and open seating is not that. It also will widen their appeal to frequent business travelers who are looking for a more comfortable option. Thank you for your attention today. I hope you found this presentation informative and beneficial in building predictive models. Take care.